Good morning, everybody. Hope you're having a good day. We are actually looking at a new chapter today. We're in chapter 8. Okay, so we're moving right along here, and basically, we're going to use geometric means today. Okay, so basically, we'll get to that definition in a little bit, but basically, this picture is really crucial for you. This picture and these two formulas, okay? So you need to basically commit this page to memory, okay? So you need to know what an altitude is. An altitude is a line in a right triangle that goes actually in any triangle that makes a right angle to the opposite side. So that green line there is an altitude, and the legs in a right triangle are basically the two pieces other than the hypotenuse. Sometimes if we can see or if we've figured out, we can call this short leg over here and long leg over here. Sometimes we know that, sometimes we don't. Okay. And the last piece you need is the hypotenuse, which in the big triangle is always across from the right angle. All right, so there's your hypotenuse. Two formulas that you need are that the altitude squared is equal to multiply the pieces of the hypotenuse separately. So this piece and this piece, there's two pieces of that hypotenuse if it's chopped up by an altitude right there. Okay. The other formula that you need is that a leg squared, either one, let's pick this guy over here, is equal to the close piece of the hypotenuse, which would be this little guy right here, times the whole hypotenuse, all the way from there to there. Okay? Now on the other side, that of course would be different. If I was talking about this leg here over on this side, now I'd be talking about this piece all the way over to the right angle here, and then still again the red line, the hypotenuse. Okay? Multiply those two together. And we're going to do quite a few examples to get you started with this. And they're quick and easy, so I think once you get going with this, you'll be in good shape. Okay? And this is actually applying a geometric mean. So in this I have an altitude, and I have the hypotenuse broken into two pieces. So quickly, and I always want to put these in simplest radical form, x squared, the altitude squared, equals 4 times 9, the two pieces of the hypotenuse. X squared equals 36. Take the square root of both sides, and x equals 6. Okay, we're talking about distances, so we will only want the positive answer. Okay. Same idea here. This is by altitude. So you always have to identify that. So 8 squared equals, okay, there are the two pieces there, x and 15. So x times 15, the two pieces of the hypotenuse. All right, so 64 equals 15x, and x equals 64 over 15, which in this case is not a very nice number, so we'll just leave it like that. 4 and 4/15, I guess, if you want to call it that. All right. Same problem, just coming different unknown. Our unknown was one piece of the hypotenuse instead of the altitude. Excuse me. Okay, this guy right here, same picture again. X is my altitude, and the only practice we're doing here is, well, let's see what happens. X times x is x squared. 6 and 15. Multiply those together and you get 90. And take the square root of 90. Oh boy, we get to practice radical simplification. All right. Are there any perfect squares that go into 90? Let's see, 4, maybe 9. Yes, definitely. So x breaks up into square root of 9 times the square root of 10, because 9 times 10 is 90. The square root of 9 is 3, so I substitute there. Does 9 go evenly into 10? No. Does 4 go evenly into 10? No. Therefore, I know that this is correct and this is simplified. 3 times the square root of 10 is my simplest radical form. All right, let's take a look at this guy. Let's see. So the altitude is 5. So 5 squared equals x times 2. So 2x equals 25, and nothing nice happening here. X equals 25 over 2, which is 12 and a half. Okay? Excellent. All right. So now, again, once you get going with this is, we've practiced this guy. Let's take a look at a slightly different setting here. Now let's look at the legs. Okay. All right. So our formula for legs was the leg squared equals the closed piece of the hypotenuse times the whole hypotenuse. So if you don't commit that to memory, you're out of luck here, okay? I mean, two things that you need to commit to memory, so you need to go ahead and make that happen, okay? So x squared equals closed piece of the hypotenuse, which is 2, times the whole hypotenuse, which is 10 plus 2, so 12. Okay, so x squared equals 24. Take the square root. X equals the square root of 24. Well, let's see. Can I mess around with that a little bit and get it in better shape? I would say so, because x equals the square root of 4 times the square root of 6, and x equals 2 times the square root of 6. Okay. Alrighty. Let's move on with this one. Now we're going to try this model again. So x is still my unknown leg. So x squared was the close leg, which is this 9, or excuse me, close part of the hypotenuse, which is 9, times the whole hypotenuse, which is 14. X squared equals 126. X equals the square root of 126. And I said, okay, well, that's 9 times 14, so that's nice that they already gave me that number. So x equals square root of 9 times square root of 14, and x equals 3 square root of 14. Let's see, does 9 go into 14? No. Does 4 go into 14? No. This is simplest radical form. All right, let's try a couple more here. So I've got the leg here, so x squared equals 1 closed piece of the hypotenuse. The whole hypotenuse is 18. So times 18. X squared equals 18. Take the square root. X equals the square root of 18, which is, let's see, 9 times 2 is 18. So x equals the square root of 9, square root of 2. X equals 2, excuse me, square root of 9 is 3. 3 times the square root of 2. Okay, so that simplification, we've done that before, but this hopefully solidifies that skill again and gives you another opportunity to see that. All right, so now we're solving for x and y in this picture here. Okay, so we're basically gonna, well, let's go with what we know here. There's nothing on the altitude, so this is a leg, so let's say the leg squared equals the closed piece of the hypotenuse, which is x, I don't know what it is, times the whole hypotenuse, which I know is, in this case, 16. The leg squared, so 12 squared, equals x times 16. 144 equals 16x, and that makes x equal to 9, which makes life easy for us here because, um, and again, this picture isn't really drawn to scale, but if this is 9, this has to be 7. Okay? You're going to run into that once in a while, so y is 7. Okay? Let's go ahead and do the last example already. All right? So now, again, find x and y. So I got a leg here, so x squared equals 5 times the whole hypotenuse, which is 7. So x squared equals 35. Take the square root. X is the square root of 35. Let me see. Does 25 go in? No. Does 16? No. Does 9? No. Does 4? No. So that's it. Simplest radical form. How about for y? There's one last look at the old altitude formula. So the altitude formula is, so y squared equals 2, this piece, times this piece 5. So that's y squared equals 10. Y equals the square root of 10. Okay? So that's your first part of geometric means, which is basically, well, how do I apply these formulas? And part 2 will be actually getting the definition of geometric mean and seeing how that works out for you. Hope everything is going well and hope you're having a great day, and we will talk to you soon.